Okay, let us go, students. Let us go and see the remaining part. So for the present states, what we have prescribed, so we have found out what are the next states we have. Okay, so for the state 6 and 7, we don't have any next state. So we have placed don't care in the place. Okay, so after that, after filling your present state and next state, you got to go for flip-flop input. Students, do you have any doubt in filling your present state and next state? Students, do you have any doubts in filling present state and next state?
No,
Table? Okay, then let me explain you how to go for your flip-flop inputs. Okay, so let me explain you how to go for flip-flop inputs. Here in the question itself, they have given us you have to use JK flip-flop, and in the step number 1, we found out we need 3 JK flip-flops in order to design a modulo 6 counter here. So for 3 JK flip-flops, we have 6 inputs. For each flip-flop, JK flip-flop will have 2 inputs, JK. So totally 6 inputs you will have. For the flip-flop A, JK are the inputs. For the second flip-flop, JB, KB are the inputs. For the third flip-flop, JC, KC are the inputs. We have to fill the content inside of your flip-flop inputs with the help of excitation table. Students, you already know what are the excitation tables. What are the excitation table for each and every flip-flop? For SR, JK, T and D, you already know what are the excitation values you will get for different present state and next state values. So let me show you what is the excitation table you can have for JK flip-flop. This is the excitation table I have for JK flip-flop. Okay, when my present state and next state are 0, 0, my J and K value should be 0, don't care. When the present state values are 0 and 1, my JK value should be 1, don't care. When the present state and next state is 1 and 0, your JK value should be don't care and 1. When present state and next state values are 1 and 1, my JK value should be don't care and 0. So keep this in the mind, students, unless otherwise you have flip-flop inputs, it is very difficult, sorry, excitation table values, it is highly impossible for you to find the flip-flop inputs here. Okay, students, once again tell me how you are filling these J and K values, excitation values, with the help of what you are filling these JK values, input values, with the help of present state and next state values. Next state values. Now let me explain you how to fill these flip-flop inputs once again. Here in the present state, QA value is 0. In the next state, QA plus 1. Present state and next state value of flip-flop A is 0 and 0. Then if my present state and next state values are 0, 0, tell me, students, what should be your JK values?
0 and don't care. 0 and don't care.
0, don't care. So if my QA and QA plus 1 values are 0, 0, for JA, KA, I will fill 0, don't care. Then check your flip-flop B present state and next state values. Here in the present state, B value is, B flip-flop present state value is 0, and next state flip-flop B's value is 1. For 0, 1, what will be your excitation value? For 0, 1, what is your excitation value?
1 and don't care.
Yeah, so under JB, KB, okay, so something you have seen wrong, students. QB value 0 and QB plus 1 also 0. For 0, 0, what is your excitation? For 0, 0, excitation value should be
0 and don't care.
So under JB, KB, I'm writing 0, don't care. Now go for QC and QC plus 1 value. QC is 0 and QC plus 1 is 1. So if you have 0, 1, 1 and don't care is your excitation values. So under JC, KC, you fill 1, don't care. Like that, by looking at your present state and next state values for each and every state, you try to fill what is your JAKA, JBKB and JCKC values here. But when you go for state number 6 and state number 7, you have don't care values. That's why you will try to fill all the don't care values under your flip-flop input conditions. Okay, since I have don't care as my next state values, you cannot find what are your flip-flop inputs here. So you try to place don't care always. Then your transition table will be completely over, students. Students, do you have any doubts still in filling the flip-flop input values? Any doubts in filling the flip-flop inputs here? How to fill JA, KA, JB, KB and JC, KC values? I will explain once again if you find any doubt in filling JA, KA, JB, KB, JC, KC values. Any doubts? Any doubt, students, in filling the flip-flop input values?
No, sir.
Yeah, if no doubt, let me go for the next step, that is K-map simplifications. Okay, for the K-map simplification. Students, here you need to find the K-map for flip-flop inputs. How many flip-flop inputs I have in the transition table, students? How many flip-flop inputs I have totally? 6. Yeah, totally 6 flip-flop inputs I have here. JA, KA, JB, KB, JC, KC. Totally 6 flip-flop inputs I have here. For K-map, for finding the value for JA, use the values which are there under your JA. For finding the expression of KA, use the content which is there under KA. For finding the expression of JB, you use the values which are there in the JB. Like that, for finding the JA, KA, JB, KB, JC, KC values, use the contents which are available under the flip-flop inputs by considering QA, QB, QC as your inputs. By considering QA, QB, and QC as your inputs. Let me show you how they are doing it. So use QA, QB, and QC as the inputs. For finding the value of expression for JA, use the content which is available under JA. Values which are available in JA, just try to fill in the K-map according to the truth table to K-map mapping value. Then try to group them and find the expressions for JA, KA, JB, KB, JC, and KC here. Students, one of the most important things that you should remember here in modulo n counters design is always the last flip-flop JC, KC should be kept your inputs as high always. If you're designing modulo 10 counter also, in 99% cases, the last flip-flop input values JD, KD should be kept always 1. So you try to map the entire K-map to get your value as 1 in here. Like that, you get the values for JA, KA, JB, KB, and JC, KC after simplifying. Then the last and final step is design part. Since you got input values to what it should be connected, go for the design part. Since we need 3 JK flip-flops, first of all, you consider JK flip-flop A, JK flip-flop B, and JK flip-flop C with its JA, KA, QA, QA bar input and output, JB, KB input, QB, QB bar output, JC, KC input, and QC, QC bar output. Since these are synchronous sequential counters, common clock is to be given for all the flip-flops. A common clock pulse should be given. Then look at your JC, KC value. What is the value of JC and KC, students? Here, what is the value of JC and KC?
1, sir.
1. So JC and KC given to a value 1 here. Then look at your KB value. What is the value of KB?
QC, sir.
QC. So KB is given to, KB is given to the value QC. Then what is your JB value? QA bar, QC. So you take QA bar and, you take QA bar and QC, multiply them using AND gate and give it to JB. Your JB also over. Go for the first flip-flop. What is the value of JA, students? What is the value of JA?
QC, sir.
So you take QB, QC as input for AND gate, multiply them using AND gate and give it as input to JA. And value of KA is QC here. Give that as input to the KA here. Okay, QC is the input for KA. This is the design of modulo 6 counter with the help of JK flip-flop. Students, any doubts in the design part? Any doubts in the design part? Students, any doubt in the design part? Tell me, I will explain you once again. If no doubts, tell me. I will go for the next part. So I have started with finding your number of flip-flops. Then I went on to see how to design a transition table. Then we have seen how to map the values into the K-map. Then from the expressions, I have explained you how to design the modulo 6 counter with the help of JK flip-flop, with which they have asked you to design a modulo 6 counter. Students, still any doubts? Just one reply. Any doubts, students?
No, sir.
Yeah. So students, here they have shown you how to design a modulo 6 counter with the help of JK flip-flop. And we can design the same with the help of T flip-flop or with the help of D flip-flop also. Let me show you the same modulo 6 counter, how to design with the help of D flip-flop. Students, I told you so many times, if they haven't mentioned you to design any sequential circuit without mentioning the flip-flop, I ask you to go for D flip-flop, since we no need to go for transition table or design table. Whatever the input you are giving, you can directly take that as your input. So most of the places you can decrease the complexity if you are designing with the help of D flip-flop. Taking that as a main part, I am trying to design a modulo 6 counter with the help of D flip-flop here. Look at here, you already know to design a modulo 6 counter, totally we need 3 flip-flops. Since I am taking D flip-flop here for the design part, I need 3 D flip-flops here, D flip-flop A, D flip-flop B, and D flip-flop C here. Look at the transition table here, students. Very simple here. No need of going for flip-flop inputs here. What is your present state? Your next state will be same. Present state and next state will be always same here. So whatever the input you are giving, you can directly take that as a output. So present, if you find your present state and next state, that is more than enough here. Then we can directly go for K-map simplification in the D flip-flop design. Whatever the values you are having in QA plus 1, QB plus 1, and QC plus 1. QA plus 1 values, QB plus 1 values, and QC plus 1 values, directly you take into the K-maps and find what is the value of DA, DB, and DC. Nothing but the inputs of first flip-flop, input of second flip-flop, and input of third flip-flop. Okay, and get the expressions and give it to the corresponding flip-flops. Your design is very simple, students. So is there any difficulty here, students? Designing your modulo 6 counter using D flip-flop? Very simple. Write your present state, write your next states, then go for the K-map simplification using QA plus 1 value, QB plus 1 value, QC plus 1 value, by considering QA, QB, QC as inputs for the K-maps. Get the expression for DA, DB, and DC. Give them to the corresponding inputs. Your design will be over, students. Students, any difficulty in the design part? Any difficulty in the design part?
No.
Very simple. So I request you to go for D flip-flop design if they haven't mentioned you to use some flip-flop in here. So if they mention you to design with the help of JK or T flip-flop, it is okay. We should definitely design with that only by designing the flip-flop input values. If they haven't mentioned you to design with the help of any flip-flop, directly you can choose D flip-flop directly. So if you, yeah, that is the advantage we have in here. Okay. Okay, students, this is about the design of modulo n counter.